Today I will take you on a tour of the database of individual seismogenic sources operated by INGV. If you go to the website of INGV, you can find a button that says Archive Banca Dati, where you can find several databases on instrumental seismicity, historical seismicity, seismic hazard, and seismogenic sources. This button opens the database in your browser. In the database landing page, you can find many pieces of information concerning the contents of the database itself. One important piece of information is the name itself of the database. This magnitude 5.5 indicates the magnitude, the threshold magnitude, for which we think we can identify seismogenic sources in the field. And this is also a threshold magnitude for damaging earthquakes, at least in Italy and surrounding areas. On the left-hand side of the screen, you can find a list of papers which have been prepared by members of this working group dealing with specific areas covered by the database, Calabria, Central Apennines, and so on. On the right-hand side, you can find links to other important databases. For instance, this link takes you to the European database of seismogenic faults. This is a compilation that was prepared in the framework of a project funded by the European Community called SHARE. And this project funded the compilation of a database of European seismogenic sources which were derived following the experience developed with this database for Italy. Going back to the main page, you can find other information that may be useful to you. For instance, how to reference the database properly, down here, or the DOI number, down here. Or you can access other pages that contain relevant data, such as a page leading you to the databases of active faults that have been elaborated around the world. In the center of the page, you will see a map that takes you to the different versions of the database for different platforms. You can download a version for Google Earth, or you can look at the seismogenic sources using Google Maps, which is the easiest possible solution. Let us now go back to the previous page. On top of this page, there is an About button that takes you to a section of the database that describes its internal characteristics. In particular, this section describes the 4 types of seismogenic sources comprised in the database. The individual seismogenic source is a source that is intended to represent a single individual fault responsible for a specific historical event. Only a few individual sources are not associated with historical earthquakes, meaning that they may eventually rupture in future earthquakes. The composite seismogenic sources are more loosely defined than individual seismogenic sources. This happens when the information available is not sufficient to subdivide longer fault systems into individual sections. But of course, with composite seismogenic sources, you can make an assumption that this type of sources may generate a distribution of earthquakes of different sizes. Then we have the debated seismogenic sources, which are active faults that have been described in the literature as potentially seismogenic, but for which the literature doesn't provide convincing data as to their existence or to their characteristics or to their geometry. Finally, we have subduction zones. In the Central Mediterranean, there are at least 3 major subduction zones, one in the Mediterranean, one in the Aegean, one around Cyprus. Subduction zones are represented as the upper surface of slabs going down into the mantle. As I said earlier, all seismogenic sources in this database are represented in 3D. They're fully parameterized geometrically. And also the database tends to completeness, meaning that we strive to identify all seismogenic sources that exist in our area of interest in Italy in this particular case. We now go back to the previous page, and from this page we can access two additional pages, one describing this working group with the name of its members and their photos, and a section with documentation on this database from its beginning. This database was conceived in the late 90s. In 2000, we published the first version. This is a poster representing this 2.0, which was created at that time and contained only individual sources and sources defined using historical information. This database has come a long way over the past 20 years with respect to this early version. If you look at this section of the database, you can find all previous versions, all versions that have been published so far, with a description of their contents. The accompanying notes file gives you an overview of the differences between different versions. For example, version 3.1, which is the current version, it was published in April 2018, features 127 individual sources, 188 composite seismogenic sources, 35 debated sources, 3 subduction zones, etc. If you need to know more, you can access the knowledge base section of the database that gives you information on what we mean exactly by the different types of seismogenic sources, how we deal with data and methods, and how we use the cartographic interfaces. Additionally, you can access a section on frequently asked questions, or you can contact us with our email addresses. Now let's go back to the WebGIS. We start from a blank page showing only the area of relevance, which is the area within which we try to accomplish completeness of the database, as I said earlier. Then, as you wish, you can add individual seismogenic sources, little boxes in yellow. You can add composite seismogenic sources, little stripes in red, where the red line marks the surface projection of the fault. The debated seismogenic sources in blue, and the 3 subduction zones. Then you can zoom in a single area. For instance, this is an area of the Central Apennines east of Rome. You can make an inquiry about a composite seismogenic source, for instance, the Salto Lake of Indoli, Barrea. This is the information that's supplied for each seismogenic source, starting with a commentary that describes how the source was defined and what are the open questions concerning it. Then you have a section on pictures describing the source from the literature or sometimes original pictures. Then a number of references, very many for this particular source, which has been studied by many scientists in the past. Plus you have a section on comments by users. And then you have a section on parameters expressed in terms of an interval, minimum maximum depth, minimum maximum strike, minimum maximum dip, and so on. Let's now go back. We were looking at the composite seismogenic source. We can now look at an individual seismogenic source. We're choosing the source of the 1915 earthquake in the Avezzano Plain. This is a very important source. It's been described by many workers, and you can see the information here concerning this large fault. The contents of the database can be downloaded from this page. Both the latest version or the previous version can be downloaded in mapinfo, Esri shapefile, or Google Earth KMZ formats. There are so many other characteristics of this database that it's impossible to describe them all in this short presentation. For instance, just talking about the cartographic interface, you can use a satellite background, or you can use a simple map, or you can use a simple map plus terrain. We encourage you to navigate the database and explore by yourself all these different possibilities. If you have any questions for us, please drop us a line. If you have comments or suggestions, do the same. And thank you for listening.